Yeah, so in the last class, we were trying to find out if we can fit 4 bars of a particular diameter within one layer. Are you with me, Shreya?
Yes, sir.
Yeah, so IS 456, you can read this clause. I hope that clause is visible to you. Clause number 26.3.2. Are you able to read that, Shreya?
Yes, sir.
Yeah.
Yes, sir.
So what does it say? The horizontal distance between two parallel main reinforcing bars shall usually be not less than the greatest of the following. The diameter of the bar, if diameters are equal. So are we providing the bars of equal diameter? Yes. So it should not be less than the diameter of bar. The diameter of the larger bar if the diameters are unequal, and 5 mm more than the nominal maximum size of the coarse aggregate. So you know the concrete is made up of cement, then fine aggregate, that is sand, and coarse aggregate. So what is the typical coarse aggregate size that we use? We typically use, Nalin, please mute your mic. We use 10 mm or 20 mm coarse aggregate. Are you with me, Shreya?
Yes, sir.
Yeah. So 5 mm more than the nominal maximum size of coarse aggregate. So 20 mm is the size of coarse aggregate. 20 mm ची खडी आपण वापरतो. So 20 mm plus 5, that is 25 mm. तो ये तीन वैल्यूज हम कंप्यूट करेंगे और इन तीन में से जो लार्जेस्ट वैल्यू है उस वैल्यू से हॉरिजॉन्टल डिस्टेंस बिटवीन एनी टू कॉन्जिक्यूटिव पैरेलल बार्स हॉरिजॉन्टल डिस्टेंस कम होना चाहिए, क्लियर डिस्टेंस. आर यू विथ मी?
Yes, sir.
So let us look at what we were trying to do in yesterday's class. 1 minute. So, so is the PDF visible, Shreya?
Uh, sir, the whiteboard one.
No, no. The PDF that I have opened just now, yesterday's class PDF, is it visible?
No, sir.
Okay. Is it visible now?
Yes, sir.
So look at this. We want, as per the design, we have to provide how many bars of 25 mm diameter. So we are going to provide 4 bars of 25 mm diameter. Are you with me?
Yes, sir.
So 4 bars. So we have placed this 4 bars, and we said that the edge distance or the cover to the clear cover to the reinforcement is 35 mm. So 35 mm gone from left hand side, 35 mm gone from the most right side. So that's what we did. We tried to calculate the clear distance between two consecutive bars, that we call it as delta. Are you with me?
Yes, sir.
So let me zoom in so that you can easily understand. So this delta, we are trying to calculate this delta. So the width of the beam is 300 mm. From that 35 mm from the left hand side. Are you able to see my arrow?
Yes, sir.
So 35 mm from left hand side and 35 mm, that is the clear cover that we have assumed, that is gone. So 300 minus 2 into 35. Are you with me?
Yes, sir.
And then we have 4 bars. So 4 into 25. That is also subtracted. So 300 minus 70 minus 100. Happy?
Yes, sir.
And how many clear spaces between the bars you have? You have 4 bars. So you have 3 clear spaces, isn't it?
Yes, sir.
So this divided by 3 is delta. Happy?
Yes, sir.
And how much it has come? That delta has turned out to be 43.33. Happy?
Yes, sir.
So let me copy this. 1 minute. So let us copy this and let me share. whiteboard with you. Share content, whiteboard, share. Are you able to see the whiteboard now?
Yes, sir.
Unfortunately, I am not able to paste anything that is copied on the whiteboard. Oh, yeah, I am. But can't undo. 1 minute. One minute. Share whiteboard. Yeah. So let me redraw that picture. Uh, are you with me?
Yes, sir.
One, two, three, four. So we have 4 bars and we have calculated that the clear distance between the bars, that is this, the clear distance between the bars, this distance. Are you with me?
Yes, sir.
This distance has turned out to be 43.33 mm, if I am right.
Yes,
Yes,
sir.
as per our calculation. So now let us check whether we place the bars at this clear distance. So what is the IS code clause? What are the clauses? So let me compute each of the things. So what is the bar diameter here? So bar diameter is 25 mm. Are you with me?
Yes, sir.
Are, are all bars of equal diameter? Yes. So there is no question of unequal diameter. So this distance delta should be greater of the following. That's what IS code says. Delta should be greater than either bar diameter, that is 25 mm, or course aggregate size, largest size, plus 5 mm, plus 5 mm. Are you with me?
Yes, sir.
So what is the course aggregate largest size that we typically use employ, that is 20 mm. So it should be 20 mm plus 5 mm. So it should be greater than 25 mm. So either you consider the first clause or second clause as per IS. This delta should be greater than 25 mm. Is it greater than 25 mm?
Yes.
Yes. So therefore, okay. So what I'm going to write is as 43.33 is greater than 25. Therefore, okay. We can go ahead with providing 4 layers, 4 bars in 1 layer. Are you with me?
Yes, sir.
So what is the reference clause for whatever we have done till now? So let me also mention the reference clause. So that is 26.3.2. 26.3.2. This is clause number 25.6. क्या था? 25 no, 26.3.2. 26.3.2. Class 26.3.2. कौन से कोड का? IS 456-2000. Are you with me?
Yes, sir.
So as per this class, delta should be greater than three things. If the bar diameters are equal, then it is the bar diameter. If bar diameters are unequal, then the largest bar diameter. And course aggregates largest size plus 5 mm. Whichever is greater is the wording. So इन तीनों में से जो greater होगा उससे भी delta ज्यादा होना चाहिए. Are you with me?
Yes, sir.
Okay. So therefore, as 43.33 is greater than 25 mm, so therefore this delta is okay. We can go ahead with the provision of 4 bars in one layer. Happy. Now what we will do next is we will try to compute what is overall depth. Are you with me?
Yes, sir.
So let us compute what is overall depth, which is denoted by letter capital D. What is the effective depth? So let me show that. Effective depth is the distance from centroid of the steel till extreme compression fiber. So it is this distance. Are you with me?
Yes, sir.
And how much is that D? So if you refer to the last class note, we have found out that we want D to be equal to 1100 mm. Are you with me?
Yes, sir.
So we know this D has to be equal to 1100 mm. So what should be the capital D? So capital D, I will zoom in this portion and redraw it here. Are you with me?
Yes, sir.
So this is the beam. This is the cut line. So this beam continues here, and from extreme compression fiber till the centroid of the steel bars, we have called that distance as small d. Are you with me?
Yes, sir.
So till which point is this distance? It is still the centroid of this steel bars. Are you with me?
Yes, sir.
Now, so to compute capital D, I have to add this distance in small d, isn't it?
Yes.
So this distance needs to be added. This distance is composed of two things. One is clear cover. So it is this distance. Happy?
Yes, sir.
Which I call it as clear cover. Happy?
Yes, sir.
And the another distance is half the bar diameter, which is this one. Uh, One minute. Distance between the center of bar till the bottom face of the bar. Are you with me?
Yes, sir.
So that is how much? Half the bar diameter, isn't it?
Yes.
So how do I write capital D? So let me write down that expression here. Capital D will be equal to, it will be small d that is effective depth, plus I will have to add two things. कौन से है? One is clear cover. Are you with me?
Yes, sir.
And the another is half bar dia. Half into bar diameter. Okay. So can you tell me how much is the bar diameter? How much is bar diameter?
25 mm.
Yes. So this bar diameter is going to be 25. So half the bar diameter is how much?
12.5.
12.5. So we know this quantity. Do we know the value of effective depth that is required? Yes. That value is 1100, isn't it?
Yes.
So 1100 and 12.5. This we know. The question is, how do I decide clear cover? Happy?
Yes.
So now I have to decide, instead of calling it clear cover, the more precise word is clear cover to tension reinforcement. Are you with me?
Yes, sir.
Tension reinforcement. Now I'm going to show you the typical arrangement of reinforcement in a beam that is required to find out this clear cover to the tension reinforcement. Are you with me?
Yes, sir.
So I hope you are now able to see the IS code. Are you able
Sir,
to see that? Yeah.
no, sir.
Uh, just a minute. Share, share contents, share screen, share. Are you able to see the IS search window?
Yes, sir.
So typical RCC beam reinforcement photos. So, so I will select this photo, this one. Are you able to see this picture?
Yes, sir.
हाँ, तो देखो इसमें टिपिकल रेनफोर्समेंट कैसे रहता है। ये नीचे वाले जो रेड कलर के बार्स आपको दिख रहे हैं जहाँ पे मेरे माउस का एरो है, आर यू एबल टू सी दोस?
Yes, sir.
Those are like 4 bars of 25 mm. They run all along the length of the beam. Happy?
Yes, sir.
Are you able to visualize that?
Yes, sir.
Then on top, on compression side also you see there are certain bars, 4 bars. Do you see here?
Yes, sir.
And on the face also, you will be able to see some of the bars. Happy?
Yes, sir.
So the section of the beam is rectangular. So width is this dimension, 300 mm in our case. Depth is this dimension. Up to the centroid of steel, it is 1100 mm, and we are trying to decide the capital D. Are you able to are you able to imagine this? Are you able to visualize this?
Yes, sir.
Okay. And are you able to see the loops of the reinforcement along this bars on tension and compression side?
Yes, sir.
These loops are called as shear links or stirrups. क्या बोलेंगे इसको? They are
Shear
called
links
as
or stirrups.
shear, they are called as stirrups in beams. Happy?
Yes, sir.
I will show you few more photographs so that this will be very clear to you. So let us look at some other beams. Typical beam reinforcement. So let me show you this picture. Are you able to see this?
Yes, sir.
हाँ, तो ये shear links आपको दिख रहे हैं which are going around the longitudinal bars. Are you with me?
Yes, sir.
Let me show you this picture. So here we have not cast the beam. We have only created a reinforcement cage. Can you see the longitudinal bars? 4 bars at the bottom.
Yes, sir.
So those are like 4 bars of 25 mm. Happy?
Yes, sir.
Then on top also we have certain bars, and around these bars there are loops of reinforcement. We call them as stirrups or shear reinforcements. Happy?
Yes, sir.
See one more beam. So these are two beams meeting each other at 90 degrees in plan. Happy?
Yes, sir.
Huh. So if I now draw the cross section of this beam, how does it look like? So let me show you the cross section. Cross section of RCC beam. हाँ. So देखो, this is how it looks like. These are the bars which are provided in 3 layers. Are you able to see?
Yes, sir.
Those bars run all along the length. Then these are the bars which are provided on the top side or compression side. They also go all along the length. Happy?
Yes, sir.
And around these bars there is a loop which is called as stirrup. Happy?
Yes, sir.
So this is how a typical cross section of beam looks like. A simplified version is this one. Are you able to visualize? These are the two bottom bars which go all along the length of the beam. Happy?
Yes, sir.
Then these are the two top bars which go all along the length of a beam, and then around that you have a stirrup. Able to visualize?
Yes, sir.
Okay, so let me draw it in our case. So let me share whiteboard, share contents, whiteboard. Are you able to see our slide back?
Yes, sir.
So what is going to be there? These are going to be the 4 bars, and around these 4 bars, around these 4 bars, you are going to have stirrups like this, isn't it?
Yes.
We just now saw this picture, है ना? And on top side also, you are going to have at least 2 bars at the corners of the stirrups. One here, are you with me?
Yes,
And
sir.
another here, so that to these 2 bars, I can tie the stirrup. Happy?
Yes, sir.
Uh, Now I will draw the zoomed in view of this bottom portion. I have already drawn the zoomed in view. In that I am going to add now shear reinforcement, that is stirrup. Happy?
Yes, sir.
So how does it look like? So that stirrup will be seen something like this. And it will be seen in double line because it is a bar. Are you with me? So it has a top
Yes,
edge
sir.
and bottom edge. Happy?
Yes, sir.
So to make it neater for understanding, let me draw the another view, zoomed in view. So you have these bars, 1, 2, 3, and 4. 4 bars. Below that, you are going to have a stirrup like this. And mind you, it is touching the bottom surfaces of all bars. Happy?
Yes, sir.
So stirrup will go like this. and it will continue. It will go to the top compression bars. And this is the outer face of the beam. Happy?
Yes, sir.
Are you with me? Now,
Yes, sir.
this distance is called as clear cover to stirrups or to shear reinforcement. Are you with me?
Yes, sir.
Uh, do you understand that it is different than the clear cover to tension reinforcement?
Yes, sir.
So let us try to write the relationship between clear cover to shear reinforcement and clear cover to tension reinforcement. Happy?
Yes, sir.
So what is the relationship? 1 minute. Let me draw this line. So this is the thing, but the diameter of shear reinforcement, isn't it?
Yes.
Diameter of shear reinforcement. Shear reinforcement. So what is the relationship between clear cover to tension reinforcement and clear cover to shear reinforcement? Clear cover to tension reinforcement. So I will call it as CT. What is CT? Clear cover to tension reinforcement. I will write this in brackets so that there is no confusion. CT. And what is clear cover to shear reinforcement? So I will write it as CS. Happy?
Yes, sir.
And what is the diameter of shear reinforcement? Let us call diameter of shear reinforcement as phi S. Phi S stands for diameter of shear reinforcement. So can you now tell me the relationship clear cover to tension reinforcement is equal to clear cover to shear reinforcement plus phi S, isn't it?
Yes, sir.
This is the relationship. Now, why do we require clear cover to the tension reinforcement? Because that CT comes here, isn't it?
Yes.
So in order to calculate the overall depth, I require clear cover to tension reinforcement. In order to calculate clear cover to tension reinforcement, I need to know the diameter of shear reinforcement and clear cover to the shear reinforcement. Happy?
Yes, sir.
So now typically we will start assuming the diameter of shear reinforcement bar. So assume, what do we assume? The diameter of, assume phi S, diameter of shear reinforcement as 10 mm. Typically, we will start as if the beam has a very light loading, we will start with 8 mm. Otherwise, we will go ahead with 10 mm. In your examination, whatever assumption you make is okay at this preliminary level. Okay.
Yes, sir.
So we assume that phi S is 10 mm. So in this expression for CT, I already know the value of phi S. That is how much? This
10
value
mm.
is this value is 10 mm. Question: what should be the value of CS? Now you have to understand CS is clear cover to the shear reinforcement. Can you tell me what is the function of this clear cover? Why do we provide this clear cover? Shreya, are you there?
Yes, sir.
See, if we do not provide this clear cover, the shear reinforcement will be directly exposed to the harsh environment. Are you with me?
Yes, sir.
Now, concrete is alkaline in nature. So uh, all environmental degradants, which are essentially acidic in nature, which are harmful for the metal reinforcement inside, their ingress will be inhibited by the presence of this cover because the concrete is alkaline in nature. Are you with me?
Yes, sir.
So therefore, the cover of certain thickness needs to be provided in order that the very first reinforcement, that is shear reinforcement, should not get corroded during the design life. Are you with me?
Yes, sir.
That is one of the reasons of provision of cover. Now, from this criteria, IS code suggests you to maintain bare minimum clear cover to the shear reinforcement. Are you with me?
Yes, sir.
So let us go back to IS code and let us see what is this cover requirement. How much cover should I provide to the shear reinforcement? So this is given by IS code. So let me share the screen with you. Again, are you able to see the RCC beam sections?
Yes, sir.
So now let me go to the IS code. Let us search cover. Ah, So look at, are you able to read this? Nominal cover to the reinforcement.
Yes, sir.
So देखो, what is the definition of nominal cover? Nominal cover is design depth of concrete cover to all steel reinforcement, including links. Links matlab stirrup. Are you with me?
Yes, sir.
So this nominal cover is nothing but clear cover to the shear reinforcement. Happy?
Yes, sir.
Because shear reinforcement is the reinforcement which is at the most outer side. It is likely to get corroded first. Are you with me?
Yes, sir.
Okay. So where is this nominal cover given? So let us look at table 16A. Can you read the title? It is nominal cover to meet specified period of fire resistance. That is one. And table 16, nominal cover to meet durability requirements. So as I said, we provide the cover to the reinforcement one to avoid corrosion of the reinforcement due to environmental attack. Are you with me?
Yes, sir.
And second, in event of fire, the temperature difference should reach steel as delayed as possible. So that is the another requirement. So we have these requirements of covers from two criteria. One is durability, which is ingress of environmental degradants, and second is from fire resistance. And these two tables of IS code give you the minimum amounts of covers that we should provide. Are you with me?
Yes, sir.
So we will not be referring to table 16A. The fire resistance is out of scope. We will not be considering it right now. We will be only considering nominal cover to meet the durability requirements. Happy?
Yes, sir.
So look at that. What exposure condition is given? Mild, moderate, severe, very severe, and extreme. Are you with me?
Yes, sir.
So how to categorize whether uh, the given zone is in mild environmental condition, moderate, severe, very severe, or extreme? Are you with me?
Yes, sir.
Uh, So for that, there are clauses given in the same code. I encourage you to read those clauses, but at the diploma level, we will always consider either mild or moderate exposure. And mild and moderate exposure will be mentioned in the problem statement. If not, you have to assume any one of these two. Are you with me?
Yes, sir.
So the dry environment like Pune comes under mild environmental category. Are you with me?
Yes, sir.
Uh, as the environment becomes more and more humid, as you approach the coastal line, it becomes more and more severe. Are you with me?
Yes, sir.
If your structure is in the saline water, for example, the bridges, uh, railway bridges that are constructed over a saline water, sea, their peers will be always dipped into the saline water and they will be subjected to alternate cycles of wetting and drying. So in such situations, the exposure condition becomes more and more severe. Are you with me?
Yes, sir.
But we are going to consider either mild or moderate. So let us consider mild exposure condition in our case. Are you with me?
Yes, sir.
And then what is the nominal concrete cover? Should not be less than 20 mm. So we have to provide bare minimum 20 mm as a clear cover to shear reinforcement. Happy?
Yes, sir.
So let us go back to the whiteboard. Share content, whiteboard, share. And in this, are you able to see the whiteboard?
Yes, sir.
So assume mild exposure, mild exposure. Happy?
Yes, sir.
Refer table 16 of IS 456 2000. Are you with me?
Yes, sir.
CS should be greater than 20 mm. Are you with me? Greater than equal to 20 mm. Happy?
Yes, sir.
So let us provide CS is equal to 25 mm. So let's provide CS, provide it in multiples of 5. 25 mm. Happy?
Yes, sir.
So now once CS is 25 mm, can I now calculate CT? Clear cover to tension reinforcement now will be equal to 25 plus 10. This equation. Are you with me?
Yes, sir.
Just give me a second. I think I switched on the video. Huh. Is that right? 35
Yes, sir.
mm. 35 mm. So we have got now the value of CT, 35 mm. Now can I plug in this value of CT in equation for D and can I calculate D?
Yes, sir.
Capital D is equal to 1100 plus half plus clear cover CT, that is how much? 35 plus half the bar diameter, that is 25 by 2, that is 12.5. Happy?
Yes, sir.
And this is in mm. So can you tell me how much is D?
Sir, 1147.5.
So are we going to say to the site people that provide D equal to 1000 whatever 147.5? No, it has to be rounded off in round it off in the multiples of 10. Are you with me?
Yes, sir.
In multiples of 10 on higher side, not on lower side. Happy?
Yes, sir.
So round it off in the multiples of 10 on higher side and tell me how much is the D to be provided.
So
Yeah,
150.
1150 mm. Happy?
Yes, sir.
Great. So till now, what is the design outcome? So let me write down the design outcome of flexure design. Happy?
Yes, sir.
Outcome of flexure design. And that will be shown by a diagram. So what is the design outcome? I'm going to provide a beam of width 300 mm. So B equal to 300 mm. Happy?
Yes, sir.
I'm going to provide beam of capital D equal to 1150 mm. Happy?
Yes, sir.
And then we are going to provide 4 bars of 1, 2, 3, 4. 4 bars of 25 mm diameter. So let me write down those. 4 numbers of 25 mm diameter. Are you with me?
Yes, sir.
And how is it shown? So it is shown in this fashion. 1, just a minute. 1, 2, 1, 2, just a second. 1, 1, 2, 3, 4. This is how we write it. 4 bars of 25 mm diameter. Are you with me?
Yes, sir.
Okay. Now I'm going to also, we have designed it till this point, but I'm also going to show the effective depth, small d. How much small d we are going to provide? 1100. Are you with me?
Yes, sir.
What is the nominal cover that we are going to provide for shear reinforcement? That is 35 mm. That I will show little later. Now, this is as far as the flexure design is concerned, but we have not designed the beam for shear. Are you with me? So therefore,
Yes.
corresponding to shear, you are going to have a reinforcement looking like this. Just a second. Corresponding to shear, you are going to have a reinforcement looking something like this. Are you with me?
Yes, sir.
And how do we prepare this reinforcement? That also I will tell you. But to hold this reinforcement on top, we are going to have 2 bars at least, which are called as anchor bars. What do these anchor bars do? So they hold this shear reinforcement in place. Are you with me?
Yes, sir.
So what is the minimum diameter of this anchor bars? It is 12 mm. So we will propose these bars are of 12 mm diameter. So two numbers uh, of 12 mm dia bars. They will be used as anchor bars. Happy?
Yes, sir.
And how is this shear reinforcement? So this in this shear reinforcement, I am going to add 2 more things. These are the things. One minute. This is called as hook of the shear reinforcement. To understand what this hook is, I'm going to show you a small video in a while. Are you with me?
Yes, sir.
But now we have not decided the bar diameter of the shear reinforcement and the spacing at which we are going to provide these loops or hoops, stirrups. तो वो हमें डिजाइन करने हैं and we are going to also have something called as side face reinforcement because the depth of the beam is very large. So we are going to have something called as side face reinforcement. So we are going to also have these bars placed somewhere here. Just now we saw the picture and you saw these side face bars running along the length of beam, isn't it?
Yes, sir.
So what should be the diameter of this side face reinforcement bars? At how many locations do I have to provide it along the face? All that design is pending. So what is our next focus? Next focus is to decide the diameter of the stirrups, the spacing of the stirrups, that is shear reinforcement, and to design this side face reinforcement. Are you with me?
Yes, sir.
That will complete the design of beam. Now, before we close for today, let me show you a small video clip on how this shear reinforcement is made so that you will understand what are those hooks which I have drawn. Are you with me?
Yes, sir.
So, are you able to see? Uh, are you able to see the YouTube screen? Check.
Yes, sir.
Okay, 1 minute. Shear reinforcement bending. Or let us say making on site. So look at this video. Are you able to see?
Yes, sir.
Let me check if it is shear reinforcement. Hopefully it is. No, it is not. 1 minute. Ha. So have a look at. Are you able to see?
Yes, sir.
Are you able to see? Hello?
Yes, sir. Yes, sir.
Hello? Hello? Are you able to see?
Yes, sir.
Stirrup make. So this is how the stirrup is made. So do you understand now what that hook is?
Yes, sir.
That hook, so stirrup is essentially not a closed rectangle. It is an open rectangle, but at the end it has hooks. And to these hooks, we bind the one of the corner bars. Are you with me?
Yes, sir.
So I hopefully now you all understood this view. Let me go back to the whiteboard. Yeah. So have you understood this view now?
Yes, sir.
Okay. So with this, we will stop for the day. We will resume our discussion in the next class.